Fire in the hole. Welcome. Today's unit came out of a Megatouch Max bar top unit, and it's a Wells Gardner 14K3101 or U3100 series VGA chassis. I affectionately call this one the Marlborough man's ashtray. This unit was gifted to me, and when it came into the shop, it smelled so bad I had to garbage bag it and keep it from stinking up the shop. I ultimately took it apart outside on the picnic table and removed the chassis, and I still think I got about a 3-pack exposure. Now, I did go ahead and get it in the wash tub, sprayed it down with some simple green, and before I could throw water at it or the brush, the yellow and green slurry of years of nicotine just kind of melted off of it and rolled off of it. But it did clean up nice. We'll go over the checkout and repair process and look at the schematic together to show how I figured out the test points to do a light bulb test and B+ adjustments, and walk on through the rest of the repair. So let's get started. Welcome to Fro-Dog Arcade Repair. Today we have a Wells Gardner 14K3101. It is out of a 14-inch Megatouch bar top unit. This particular Wells Gardner can also be known as the U3100. I affectionately call this one the Marlborough man. And yes, I do know I misspelled Marlborough on my splash screen for this particular video intentionally. I don't know if that's really a copyright problem I need to worry about or not, but I did misspell it and did not use any of the Marlborough imagery, or logo I should say. A yellowed, crusty, smoking cowboy is definitely kind of the Marlborough image, but anyhow, that's my tongue-in-cheek for it. This thing has definitely been around a bar. As you could see in the intro of stills showing me washing the Marlborough man in the sink, all I did was spray simple green on it and the nicotine and yellow goo just rolled off. So it no longer smells like an ashtray, and everything's pretty squeaky clean. But the problem that was stated with it was it powers on, not necessarily the best picture, but it did work. So after cleaning it and got on the bench here, we're going to do our visual inspection. The first thing I saw is somebody else has been in this chassis before, and to me that's evidenced by this melting here on the CRT socket cover. Oh look, our focus wire just broke off, and kind of goobered here at the focus pin on the CRT connection. I've got our signal cable off. This particular unit is VGA, so it is new enough that it's a VGA. I'm going to have to power it up with a laptop with an external VGA connection to see it function. But initially on inspection, the other thing I noticed was just when I was washing it, I saw somebody had cracked a piece of the board off here. Now, I had used a repair technique with welding powder and CA on a couple other boards that had corners chunked a little bit, whatnot. It's not mission critical. It does not affect any of the traces. It barely touches the corner of this ground plane, but I'm going to still see what I can do to make a little bit of board out here. I think it'll take some Dremel shaping and whatnot to make it happen. But top side of the board, first thing I did see were some bulged capacitors. This one right here is especially bulged. I don't know if you can see that. You can see how it reflects the light a little differently. The top's bulged and it's all kind of pushed to one side. I think it was just about ready to SpaceX launch from the board. This one back here in the power supply section's a little bulged. It looks like we have a switch mode power supply set up. We come in, we have bridge rectifier, then we dive right into our switch mode section. I'm going to try to figure this out as we go on a light bulb test and whatnot, but I think one of the first things I need to do at minimum is replace our SpaceX cap here that's ready to shoot for the moon. And maybe, I don't know, we'll just touch a couple of these with the capacitance meter and see if they're anywhere reasonable within spec. And then we'll, don't find anything egregious, we'll try to light it up. But I do have a full cap kit for this unit. And let's start. Let's finish an inspection on the bottom of the board here. Just looking around, looks like there might have been a little reflow here. Those two pins are shorted together, but they look like they're on the same trace, so that should be a non-issue. Looks like there's been a little bit of reflow back here in this corner of the power supply. Nothing significant. The 3 pins on this transistor definitely need some help. They look a little ringed. Got our yoke connector, which doesn't look the greatest, but doesn't look bad. It's not broken, but it'll definitely need some reflow for longevity and reliability. But for the most part, yeah, I don't really see anything going on. Got to fix that focus wire that's broke off and tidy up that work. This has got so much white goo on it I can't see a whole lot. Let's just go over it with a paintbrush and a little bit of denatured and see what it looks like. See if that gets us. Oh yeah, the white stuff I'm sure will come back as that alcohol dries, but looks like our color transistors could use some reflow. Nothing broken, but they don't look the best. All 3 of them. Neck socket looks like it has been reflowed. Anything on here aside from that focus wire haven't been melted and fooled at. I'm trying to see if it looks like anything's been replaced or done here on this neck board. Our 3 color power transistors look resistors look pretty good. Not even folded over that bad. Got a couple of components laying over on the board. Nothing serious. Bunch of little caps on this board. A couple of pots that do not look like they've been moved from their factory positions. As with any board, we'll reflow headers, pin and plug headers, but they don't look that bad. I would say in general this looks pretty decent. We might get lucky and really have nothing more on this than some bad caps and bad solder joints. But at minimum, we're going to learn how to figure out, hopefully, and then call it learn how to do a light bulb test on it. Just that little bit of alcohol over the board sure makes that white flaky stuff look a little better, so we can actually see the connections and whatnot. There's a little bit of reflow goober work here. Overall, I don't think it looks too bad. Let's look at this remote board real quick. It's the only other board we haven't really looked at. Oh, well, that's interesting. That's somebody's modification on a pot. I would say that pot went bad. I would say they drilled this hole and put a wire to it, and then use these other two holes as mounting points for a pot. It's pretty creative. Not terrible work. We can tidy it up a little bit. We'll probably close those holes with some solder, reflow these headers, and once we scrub that up and get rid of flux, I might even leave that wire there. I'll trim that end a little bit. We'll get some conformal coating on it and make it look a little better. Alright, I am going to start by pulling our, as I'm affectionately calling it, our SpaceX cap. And that's one that's been replaced before. I can tell by the solder joints on it. I wonder if it's like a TPO or something is why it's going bad. TPO, you need some caps bad? We've got some bad caps. TPO was the first off-brand cap I ever tried once I got into the monitor repair stuff early on, doing a couple for myself. And bought them on Amazon. I thought, you know, for a discrete component, how wrong could you go, right? So I bought them. I put a couple into a K4600. They failed within about 90 days. And I noticed within a year, all the spare ones, because they came like half dozen, in the bag was all gooey inside. They'd all been leaking in the bag just in my parts tray. So, not a big fan of the old TPOs. This is a WinCap brand. Not familiar with WinCap. Might be great, might be bad. Kind of like KMF. First time I saw KMF, I'm like, well, that sounds like a cheesy cap. But turns out KMF is actually a pretty decent known brand. Oh yeah, look at our goobers on the board down here where that cap's been leaking. Let's clean that off. Okay, it looks like the nomenclature on this board is shaded for negative, because we've got a plus symbol on this side. I think the shaded side is going to be our negative, and based on how this was in there, it was also in that way. I would believe this has been in for a little while, and that was probably not put in backwards. Let's just take a quick look at a couple of others. Yeah, everything I see is shaded that way. WinCap seems to be the consistent brand on at least the larger ones. I wonder if that was a cap kit somebody did a while back, and those were the brand available or what they used. But I'm dying to know this this swollen cap here. Let's see what it looks like on our capacitance meter. 100 mic, 160 volt. Positive, negative. Well, we're not getting out of the Pico farads, and we're not getting an ESR rating at all. It definitely toast. My guess, open. Alright, I got a little deoxit down on all of our pots and got them cleaned up on the neck board, and got the broken off wire out of the CRT socket. I wanted to show you how I do focus wires on CRT sockets. Some folks just tin them, stick them straight through. Some try to wrap them around a bunch of times. I like to just bend my tinned focus wire into a nice little hook, and then put it on opposite of how it's going to lay. Kind of stick the hook through, rotate it around, and then I can take my pliers and squeeze my hook just a little bit to make a good mechanical connection. have it laying where it's going to go for the little cap on the focus wire to close, then lay my solder on the focus tab. That gets us a good soldered electrical connection and a good physical mechanical connection. Then we can close our cap. Actually, our cap is still a little boogered up here. Someone's melted at it, looks like, with a soldering iron. Let's see if we can clean a little more out of that. And get a nice good closure and clip action out of it here. I think I'm going to get our hot air rework gun and without melting our wire harness here, try to get a little heat in that, get that bent over just a little bit so it has some positive latch going on. Try to do the same thing over here a little bit. Just need to soften it, not melt the Jeezys out of it. Now if you look, we've got a nice little inward bend to both of those tabs, and now they lock solidly on their latch below. Welcome back. I took a look at the schematic. I'll show it to you here. Looks like our B plus comes off of this pair of diodes. In the schematic it just shows a single diode, D609. On the board we have a pair in series. Goes through L605 and then out to the rest of the chassis. Now tracing the traces on the bottom with a meter for continuity. We can grab B plus over here at J602, or being such a small coil, I think we could grab the B plus maybe easier and more efficiently right here at the cathode of D609. So I think that's where I'm going to try to grab it. Our HOT, I have our collector lifted, so we will have no high voltage. But to show you that path, here is our L603. This is our D609. Comes off, comes over through that little coil, clear on over. There's our jumper, and it comes right over to the flyback through a coil in the flyback straight to the collector. So the resistance of this coil integrated in the flyback and L603 are de minimis, so it really shouldn't make that much of a difference, but that also leads credibility to our whole, you can always find your B plus on the collector of your HOT. Like I said, I think a good place to grab it is back here at D609 on the cathode, and we'll give that a whirl for our stage 1 B plus light bulb test. Let's get our neck board and our remote board dangling off the side of the bench here and out of the way. Get our board over close to the edge, our meter in frame, our light bulb right up there at the top of the frame. We can grab ground off of the chassis over here. And then we can take our light bulb ground, parallel it right across there. Let's get our meter on volts DC. Get our test point positive and our light bulb ready. And I'm going to sneak right in here, touching nothing. Perfect. Nice big area to clip onto on that cathode. Things are in frame. Just in case there were some way it touched, since I didn't pull that HOT all the way out, I did stick our high voltage anode in our trusty Pac-Man glass jug. All right. Now let's get some AC. And this has pushed me to really think about, I got to find this 3-pin Molex and make a true connector for it rather than these suicide gator clips. But we'll get our AC connected with our suicide cord. All right. Insulated, meters on, light bulbs there. High voltage anode separated just in case. AC. Fire in the hole. Oh, and we got nil, nada, nix, zilch, none. There we go. I have a bad connection here for my AC cord. Might be time to change that Molex. But alright, we've got 107.3. Our light bulb is lit up. I have not found a B plus number for this. I'm going to guess it's 100 volts. I haven't touched the pot. Our light bulb is a decent analog to a CRT. But we got our chirp, we got our power supply up and running. And let's push that over just a little bit. We've proved out our power supply is good. I'm going to solder that collector back in on the HOT, and let's go to a stage 2 and see if we get any high voltage. Oh, before we move on, let's see if our B plus moves or adjusts at all. 107.2 is where we're starting. Yep. Let's put it back to where we found it. There we go. So B plus adjust, I feel confident we found a good B plus point for this chassis via the schematic. Now we're ready for our stage 2 light bulb test. We're going to see if we've got the high voltage and horizontal circuits working. Same test points, ground, cathode of D609. We've got our AC connected. We've got our neck board and remote board dangling out of the way. Now, this time we've got our trusty glass Pac-Man mug. Danger, high voltage, Will Robinson. Where we're going to put our high voltage anode to insulate it and get out of the way. And on this test, we're going to look for a little bit of snap, crackle, and pop down in that jar. We'll listen for that. But we're hooked up. Fire in the hole. Power supply's up. With the high voltage circuit in line, we're 1017. I think we're 100 volts for this chassis B plus when we're all done. And I can hear some ever so slight snapping in there in our glass jar. So horizontal output, high voltage section is up and running. Welcome back. We have our U3100 14K3101 on the bench on the tube. We have not done our cap kit yet. We want to see it light off. So no time like the present. There we go. Fire in the hole. Alright, heard our high voltage come up. Let's get our test pattern generator here turned on. Oh, I see something. Alright. It works. So, we have red, green, blue, decent white. It could stand to have some dial-in work, but our geometry looks good. So the chassis is working. We just need to fix that chunked off corner area and finish our recap. Our next step with the Marlborough Man's Ashtray is going to be to fix this chunked off board corner. So let's start with some tape. And we're going to use our welding powder to fill in the areas. Need a good stable substrate for it to lay on. Let's see, what are we sitting on that's not letting us go flat? I think it is just components and whatnot on the bottom of the board. Alright. And we put under this end. That's a little too much. Alright. We're just going to play this one by ear, I reckon. Somewhere out in like that area is going to be what we need to fill in with welding powder. Now it's not going to be exact in this application. We might have to build a couple of layers to get there, but we'll Dremel down what we don't need. I think we're going to have a good little bit of extra on there. I try to get the stuff that's kind of granular laying on the board itself kind of brushed over into place so we don't the thin super glue will kind of wick and it'll leave a rough texture on the board itself. But I think we're ready to start applying our super glue and making our welding powder solid. Okay, that seems to have done pretty decent. Let's hit it with just a little bit of the CA accelerator here. I know it's a different brand product than what we're using, but CA should be CA. Good old cyanacrylate is cyanacrylate, right? Or at least we hope. Now, let's tilt that up. Looking at it out here, I think we're a little thin right in this area. So let's add a little bit more. Gets pretty hard pretty quick. That was a little interesting phenomenon that I haven't seen before. Is it kind of looks like the CA may not have soaked all the way through to complete that. So we're going to put a little bit in this groove that's now missing. We'll apply CA from the bottom. Before we do that, save us a little bit of grinding if we can screed a little bit off first. Okay. That hardened right up. Looks like we will have to clear that hole out just a little bit. There we go. All right, I went to the bench grinder and did some just some rough shaping to get us in the general direction. Comes off a little quicker on the bench grinder. Okay. All right, back with our cap kit. Looking back at our chassis, we can see our repair on the corner here. I'll probably never get an award for color match, like probably shouldn't hire me in the body shop to paint your car, but it is not the stark white of the welding powder and CA. I tried to match it a little closer to what the top of the board looked like. And then on the bottom of the board, I coated that new corner repair in a little bit of the conformal coating and UV cured it, so it had that green cast to it. And on our remote board, we had one pot that had been replaced previously, and it had a new hole drilled and a wire ran in this fashion, and I just conformal coated that little area after I cleaned it up. So we have those professional repairs to the board, and we have our completed chassis, and do our 24-hour burn in and be all done. Alright, here's our wrap-up video. We've got our Wells Gardner 14K3101 U3100 series chassis back on the tube and yoke after our recap, reflow, and cleanup. Got our test pattern generator. There's our grayscale. Some color squares. Good looking color bars. Teals down to black. We got good geometry. Not much blooming effect with the black-white shift. White looks pretty clear. Blue, green, red. Back to our grayscale color bars. So I'm going to let this one burn in on the bench for a day, and we're going to call it a wrap. Thank you for joining me. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below, like, follow, and share with your friends. And remember, fire in the hole.